Okay, in this lesson, we are going to continue with chapter 10.5, and we will talk about scientific notation for the latter half of this unit. So in this lesson, we will talk about reading in scientific notation. So I can read scientific notation is the objective for the day. Okay, so a number is written in scientific notation when it is represented as a factor, represented as a product of a factor, and a power of 10. So everything in scientific notation is in the power of 10. The factor must be greater than 1. So the factor is the number in front, and less than or equal to 10. So take a look at this example here. I'll let you write while I talk a little bit. So this example right here of 8.3 times 10 to the negative 7 is a number written in scientific notation. This number right here in the front is what we call the factor, and this number right here in the back is what we call the power, right? So notice how the factor is 8.3. Notice how this factor is greater than or equal to 1 and less than 10. Excuse me, I actually made a mistake in the writing. It should be the factor must be greater than or equal to 1. I apologize. And it must be less than 10. It cannot be equal 10. I apologize for that. Okay, so you can't have a 10 times 10 to the power, right? It must be less than, so it must be 9.9. The power of 10 has an integer exponent, right? So you can't have a decimal, you can't have a fraction as your power. All right, so here's how you identify numbers written in scientific notation. Okay, so step one, you look at the factor. Is it in between 1 and 9 and 1 and 10, right? Is my number in between 1 and 9, 1 and 10, and is my power of 10 an integer? Let's take a look. 5.9 is my factor. Notice how this is less than 10 and greater than 1. So yes. And notice how this number is not a decimal or fraction. So this would be yes. That's all you got to do. All you have to do is tell me, is it in scientific notation or not? Okay. Let's take a look at this one. I have 0.9. Is this number written in scientific notation? And the answer is no. Why? Because 0.9, this is less than 1. Right? Remember, for it to be scientific notation, it needs to be greater than 1. So this is not in scientific notation. Okay? And that's all you have to do. Just tell me if it's in scientific notation or not and why. All right? All right, let's take a look here. Writing numbers in standard form. Okay? So writing numbers in standard form is the absolute value of the exponent indicates how many places to move the decimal point. So if the exponent is negative, you move the decimal over to the left. If your exponent is positive, and I will explain what all this means in a little bit, you move the decimal over to the right. So let's take a look. So if I'm going to write 3.22 times 10 to the negative 4 in standard form. Standard form is like what we're used to, like 500,000, right? Like 3.2, that is what we call standard form. So if I were to move, right now this is in scientific notation, 3.22 times 10 to the negative 4. So what I would have to do is step one is write 3.22 down first. Okay, so that's what you would do first, right? 3.22 down first. That is my factor, right? And then take a look. My exponent is negative. You move to the left. Okay, you could think about this on a number line, right? The more left you go, the more negative you go. The more right you go, the more positive you go. So if my exponent is negative, then my decimal is going to move to the left. So I'm going to move it 1, 2, 3, 4. Okay, so I'm going to move it over 4 places, and so my new decimal is here. All right, and then with the blank spaces, I'm going to write 0. So 0, 0, 0. So my final answer is 0.000322 in standard form. Okay. So now let's do another example. I have 7.9 times 10 to the 5th. So as always, you write 7.9 down first. Notice how my exponent is positive. So if it's positive, you're going to move to the right. Right? My exponent is positive 5, so I'm going to move my decimal over to the right. 1, 2, 3, 4, 5. So here's my new decimal. Blank spaces, you add zeros. So it looks like this is going to be 790,000, so 790,000 in standard form. All right, so why don't you try 1, 2, 3, and 4 on your own, and then we'll continue on with this lesson. All right, example number 3, comparing numbers written in scientific notation. Okay, an object with lesser density than water will float. An object with a greater density than water will sink. Use each given density to explain what happens when you place a brick and an apple in water. So some of you may be like, well, duh, this is obvious. Brick is going to sink and apple is going to fall. I really don't need to do math to know that, Mr. Kim. But I want to encourage you to always prove to me that you know, not just show me because you think it's going to be. Always prove to me that it is the case. So that's what we'll do. So let's take a look here. I would write each of these numbers in standard form. Here's the density of water. Here's the density of a brick. Here's the density of an apple. Let's write each of these in standard form. If I have 1.0 times 10 to the third, notice how my exponent is positive. So I'm going to move my decimal over to the right. 1, 2, 3. Blank space, you add a 0. So this is equal to 1,000. Okay, so the density is going to be 1,000 kilograms per cubic meter. Now let's do the brick. I have 1.84 times 10 to the third. 1.84, my exponent is positive. Move it over 3 places to the right. 1, 2, 3. Add a 0. So you get 1,840 kilograms per cubic meter. And then my apple is 6.41 times 10 squared. 6.41. You move my decimal place over 2 times to the right. So you get 641. Right, so if a density is less than water, less than 1,000, then it'll sink. More or float more than water, then it'll sink. So for example, I can say that because the apple is less than water, apple's density, then apple will float, right? And the brick's density is greater than water, so the brick will sink. Okay. All right, let's move on to this last example right here. A dog has 100 female fleas. How much blood do the fleas consume per day? Right, so a dog has 100 female fleas. If there's about 1.4 times 10 to the negative 5th liters, right, per day. So let's take a look. So what do you think I would do if one female flea consumes about 1.4 times 10 to the negative 5th liters of blood per day, and the dog is 100, right? I'm going to be multiplying it by 100, right? So I'm going to do times 100. So how do I multiply this if it's in one's in scientific notation, the other one's in standard form? I would move everything into I would move everything into standard form, right? So you can take 1.4 times 10 to the negative 5th into standard form. We learned how to do this, so I won't write an equal sign here. 1.4, because it's a negative exponent, you move it over to the left. 1, 2, 3, 4, 5. Here's my new decimal, 1, 2, 3, 4 zeros it looks like. So I'm going to do 0.0000014 multiply it by 100. If I'm multiplying anything by 100, all you have to do is move the decimal place over, right? Because it's 0, there's 2 zeros here. I'm going to move it over once again. 1, 2. So it's going to be 0.0014 when I multiply that out, right? So just don't be afraid to always be moving decimal places out every now and then, but that's just how you do it. All right? Well, that's it for today's lesson. All we're going to do is read and write numbers in scientific notation. Circle your level of understanding, and please upload a picture of your notes for today. I will count that as your attendance points for today. So make sure you're taking pictures of your notes and uploading that, and then also do the same for the BIM onto Schoology. If you have any questions, we'll go over any questions on the next day. Bye, everyone.